Welcome back, everybody. I hope you had a good refreshment. I took my cup of tea, but it's still too hot to drink, so I'll put it aside. My computer also needed a refresh, so if you can't chat or you can't ask any questions, just refresh the computer and, well, hopefully it's going to be fine. And if not, it's just like the weather. Wait for a few minutes and it's going to change anyway. We have two next speakers, Mark Higgins, who we already saw, and Garrett Williams. About Garrett Williams, I would like to tell something. He's a British-German aerospace engineer, originally from Edinburgh in Scotland. He lives out in the Odenwald Hills. That's a bit of Scotland in Germany, I understood. So my bucket list of going places is growing now. I want to see this. He likes his family, his dogs, his job for you, and singing. Badly, he says by himself. But it doesn't matter. Yeah. Whenever you sing, it's good for your body. In the car or on his way home, that makes him happy. And in his spare time, he does a lot of walking, reading, go to concerts, and do it your own around the house and the garden, or even riding motorbike and traveling. Sounds cool, Garrett. Sounds really cool.
Let's be fun.
We're going to listen to you later on. First, we go to Mark Higgins, because Mark would like to show us around in what normally would have done be physically, but this can't. So discover EUMETView, an online map service that provides data visualization through a customizable web user interface. Well, Mark, show us.
Okay, so thank you, Helga. So what I'm going to do is just show you a tool that is useful for following some weather events. Now, this tool is aimed at meteorologists and scientists and a little bit the general public. It's a general purpose tool. Some of the stuff you may not want to use because it's not quite broadcast quality, but you'll have access to the broadcast quality images you need. But what it will do is give you a global view of what's happening around the world. So I'm just going to go through a couple of events that I found interesting that have happened over the last 6 months and show you some of the features of the service. So when you land on the service, and you can go there now, it's view.eumetsat.int. You'll see what we call the Airmass RGB. So this is showing the water vapor and temperature and sort of bulk temperature of the atmosphere, plus a little bit of the rainfall products from the hydrology SAF. You can then log in, and if you're logged in, you get a few more features. It's a web map service, so you can scroll and zoom around the whole of the globe and see all the data that we have available. So this is a tropical cyclone from the mid part of last month, so the mid part of the 17th of May 2021, that was just making landfall on the west coast of India. And this is what we call the natural color enhanced image. So you may be familiar with the EUMETSAT imagery. When we make the natural color imagery, normally the clouds are cyan because the channel combination we use actually has an ice-water discrimination built into it. And so the ice clouds are cyan, but here we've made it a much more public-friendly version. So we've made the clouds white, and you can see that strong circulation center. Now, what I can also do is I can log in, and I've actually got this saved as a view, so I can go back to it and have a look at any time. So it's saved in sort of a case view. So those of you who are involved in public outreach who want to store and look back at certain cases, this is a really useful functionality. And you can also share that view with other logged in users. So the login is free, you just need to register, but the ability to share views is really quite useful. So, and Tony mentioned this is the scatterometer data that I've laid on top of that cyclone. So what you're looking at is the winds over the ocean surface. Now, the scatterometer, it's a spaceborne radar. It sends down radar energy. It gets the energy that's reflected back off the ocean surface back towards the satellite. That amount of energy that goes back towards the satellite, it depends on the wind speed. We measure it in 3 directions. We can get wind vectors. And so that's what we have here over the ocean. So wind vectors every 12 kilometers. And you can see the tightness of that circulation center and the strength of the winds inside. And if I zoom right in, we flip over to wind barbs, which will be familiar to many of you, and you can see that circulation center again. Just like to point out on the right hand side, you can also click on a pixel and see some of the details to do with the winds at that point. And if there's multiple observations, you'll see all of the information. So it's quite a useful little roaming feature that you have there. So stepping on, recently, it's not only Iceland that has volcanoes. There was recently a volcano in the Democratic Republic of Congo, obviously had quite an impact for the community who live nearby to it. So this is on the eastern side of DRC near the Rwanda border. This is that volcano seen from the ash RGB. The ash RGB is tuned for microphysics and particular ash. Now, this particular volcano, the eruption was quite gentle. There wasn't much ejected up into the atmosphere, so you can't see a strong ejection signature. But what you'll see if I just step through in time, you can see just a tiny signal there on the DRC-Rwanda border that indicates a very, very high surface temperature. And I'll just zoom right in onto that, and you can see where that volcano eruption happened. And this is one thing, so we were able to pinpoint in time the exact moment of the eruption starting. Obviously, the ash RGB, you get quite a nice view across the whole region. So it's what we call a microphysics RGB. So you're seeing a whole bunch of features. But when you see ash and SO2, you'll see this green plume coming away from the volcanoes that eject a lot of stuff up into the atmosphere. We can also have a look at one of my favorites, which is the dust RGB. Dust, the RGB is tuned for dust, but actually you can see a whole range of features. So you can see up in the top left, I've marked it as dust, that pink that is associated with the lifted dust. And if you've been following the dust event now, as dust, there's a slow, steady stream of dust flowing over from West Africa over towards the Caribbean. You'll see those pink hues, and you can actually follow the journey of that dust. You'll also see here the yellow indicates water clouds, the red colors indicate deep clouds, so optically thick with very cold tops, so usually the top of the CBs with the ice on top. And the thin black, what you see is the wispiness. That's usually indicative of high thick particles, so you're looking at the thin ice areas. And you can also see there's sort of variation in the hues of the blues around these tropical systems, and they're associated with the moisture boundaries. So a lot of forecasters in the tropical areas are also using this to just track moisture boundaries and see where the convective cells might be initiated. We also have low Earth orbit data on. So one of the challenges we have with EUMETView, with the View service, is not only displaying the geostationary stuff, but also being able to display low Earth orbit data as well. So we're able to do that, and you can see this building up a picture. This is from the Sentinel-3 instrument. This is from the 26th of May this year, and just sort of building up that full picture. And you can zoom in and you can see. Now, if you go to the end of each day, you'll get the full day's imagery if that's what you're interested in seeing. But you may be interested in imagery that's come in earlier during the course of the day. The Sentinel-3 imagery you can see, so this time of year, we're not seeing much of the southern Arctic area because there's not enough light. We're seeing a lot more of the northern Arctic area, but not the southern Arctic area at this time. If I zoom in, and this is a case from June 17, if I zoom in a little bit, you can see, sorry, this is January 17. In this side, the red circle, you can see a small bright blob. And that's actually a chunk of iceberg. So this was an iceberg, this was from January this year, iceberg A68A, that had actually cleaved off from the Arctic Ocean and traveled north to the Sandwich Islands. And you could follow it quite well using the View service. If you're also interested in this kind of feature, following it using the Sentinel-1 radar, which is available through the European Space Agency and Copernicus, is also really interesting to do. Pardon me. We also have a feature, so we can show, this is from the AVHRR satellite, instrument on board the METOP satellite. So we're showing the daytime imagery and the nighttime imagery. In the day, you're seeing those cyan clouds. In the nighttime imagery, you're seeing these bright colors. And again, this is a microphysics RGB, so it's showing up different microphysical features. But if I zoom in on this one, you can see this was iceberg A76, which was cleaving earlier on last month. So this thing is about 300 kilometers long, and this was from May the 15th. Obviously, we can't see it in the daytime imagery, so it's not as clear as that previous image I showed you, because it's just not light enough to show it at this time. And of course, you get the full beauty of the full disk image. Now, what we'll be doing for the new programs is putting data on here as the satellites are launched and we go through commissioning, so it's all available to you. And if you have feedback on how this service can be more useful to you, we'd really like to hear, because what we think is that obviously it's useful to scientists who are wanting to find cases and then go and get the data and explore further. But for people involved in storytelling, again, you might want to find cases around the world, go and get the full resolution data, or just use it to quickly share stories or just keep an eye on environmental phenomena that you are interested. Thank you very much indeed.
I am in?
You're in.
Yes. I was unmuted. Nevertheless, Mark, someone says, Simon Proud says, your UMET view looks different to the one I see. Is this an upcoming new interface?
It is, yes. So if you've gone to eumetsview.eumetsat.int, and Simon is one of our regular users, so he will have actually had access to an early version. If you now move over to view.eumetsat.int, you'll see the updated service, and that's probably the one you want to be using.
Okay, I saw that also in the chat, new upcoming chat. For me, it was a little bit confusing. If there is a new session opened, then also a new chat will be opened. But if you want to review the old chats, you can go back to the old program, click on the program, and then you should see the old chats with maybe the suggestions which were put in. So
view.eumetsat.int. Yes, and I'll put that in the chat and in the profile.
Yeah, in the partner section. We can always find it in the partner section. That would be great. We also have a poll, poll number 4. Please, people, go into the poll section. You have chat, question, and poll. Go to poll. And there's a question: as extreme weather alerts become more common, do you think EUMETSAT View could help you visualize their evolution better? Do you think so? Then you say yes. If you don't think so, well, say no. Are there any other options?
Yeah.
Are there other options?
But you can post comments in the chat. Post comments in the chat.
That's always great. What's your dream for 2030, Mark?
I guess in terms of the satellite program, so I mentioned earlier about sort of fires and stuff. I think in terms of outside of the satellite programs, you'll see the Mauna Kea carbon dioxide curve that we're a little bit familiar with that keeps on going up. I think my dream for 2030 is to see a change, a downward kink in that curve. I'm going to leave that one there.
Well, changing the curve is not that difficult, but changing reality must be much more difficult.
Yeah.
And in personal life, because we like to meet you as a person, what would you reach in 2030 as a person?
I was looking through the list of participations to this conference, and there's a whole bunch of people that I've actually met from Europe and Africa mainly. And I think one of the things I'd wish for 2030 is partly being able to see all those people again, because they're wonderful and I miss you all. But the thing about this event is this is one event where we're having both of these audiences in the same place and talking. And I think to be able to do that face to face again would be really sweet. I'm loving this, that we can do this, but I'd love to see everyone again as well.
I think that dream is mutual. Yes, I think so. For so far, let's go to Garrett. Garrett, you're head of the Flight Operations Division of EUMETSAT. And you're going to show us something, what's happening in the mission control room?
Yeah, I'm going to give you a little bit of a tour of our control center and give you an idea of what the kind of things we deal with in there.
Well, let's take a look.
Hello, I'm Gareth Williams. I'm the head of flight operations for EUMETSAT. Welcome to EUMETSAT's Mission Control Center. From this room, we operate 4 Meteosat spacecraft, our geostationary satellites, 3 METOP satellites, which are in low Earth orbit, and we also operate 3 other spacecraft on behalf of the European Commission, Sentinel-3A and 3B, and Sentinel-6 Michael Freilich. Once the data is downloaded to a ground station, and we have several of them around the world, that data is sent back to the EUMETSAT headquarters here in Darmstadt. When it's received, it's processed and turned from bits and bytes into a more usable format, and it's then sent on to our users, both in the EUMETSAT member states and around the world. All of the data that's produced within our processing systems is also archived in our data center, and that means that we have one of the largest climate data record archives in the world. Behind us you can see numerous screens which are providing information to the operations controllers. These tell the controllers where the spacecraft are at any given time. It tells them what the configuration is and the status of the satellites, of all the systems on the ground. These screens also allow them to see the schedule of activities that are planned or have been performed for the day or for that night. And lastly, it also gives them an at-a-glance indication of whether anything is not going according to plan. The satellites that we operate and the ground systems we use to support them are highly complex. Our spacecraft use cutting-edge technology to acquire the data that we need, but they also have to be highly reliable because we can't simply go up into orbit to fix them if they go wrong. EUMETSAT's ground systems are not just located here in our Darmstadt site. We're also around Europe and across the world. We link into the operational systems of a lot of our international partners as well. Lastly, we have 2 backup control centres, one in Spain and one in Italy, which allow us to keep control of the spacecraft should we have a problem at this location. With systems as complex as these, we have to rely on automation. We have software that scans through the telemetry from our satellite and from our ground systems to identify anything that indicates that things may not be going as planned. We also follow the flow of data and products through our system to make sure that it's meeting our requirements for quality, for timeliness, and for completeness. Any deviation is brought to the controller's attention. In many cases, the system or the satellite can correct the problem itself, but where that's not possible, the controller can act using procedures we've already tested in advance to either protect the spacecraft or to restore the services to the users. Satellite commanding begins with a schedule of activities. These are implemented using a set of procedures which have already been tested thoroughly in advance. For older spacecraft, that schedule is maintained on the ground, and we transmit the commands to the satellites frequently. For newer spacecraft, they're able to decide for themselves what activities to perform and when, usually based on where the satellite is in orbit. The planned activities are turned into individual commands by our mission control system here in Darmstadt. From here, they're transferred via ground stations in Romania, in Italy, in Norway, and in America for uplink to the satellites in orbit. But ultimately, the spacecraft is capable of looking after itself and keeping itself safe until we can recover it. EUMETSAT offers a number of different means for users to gain access to our data. Our EUMETCAST system offers both satellite-based and internet-based transmission of data. We also distribute data using the channels that are provided by our operational partners. And lastly, we also provide users with the option to request data directly from our archive. Satellites often live considerably longer than their design lifetimes. This is because they're engineered for reliability, and quite often we find that fuel is the limiting factor in their lifetime. This is true of EUMETSAT satellites. Our METEOSAT 8 and our METOP-A satellites have both lasted more than 3 times their originally intended design lifetime. But eventually all spacecraft reach the end of their usefulness and they have to be disposed of. This has to be done to avoid contaminating the space environment, which is essential for humanity. With geostationary satellites, this is done by moving them higher above the geostationary ring so that they're several hundred kilometers above their current position. Once they reach that point, they have to be passivated so they don't represent a risk of explosion in the future. We do this by disconnecting the batteries so that they can't explode. We vent the fuel tanks and we switch off all the transmitters so we can't interfere with other satellites. Late next year, the first of the METEOSAT second generation satellites, METEOSAT 8, will come to the end of its life and it'll be reorbited. For our low Earth orbit satellites, the approach is slightly different. For these, we lower the spacecraft's orbit. In fact, we place it into a descending orbit that will result in it burning up in the Earth's atmosphere. For older spacecraft, this can take up to 25 years. Once it's in that descending orbit, we passivate it the same as we do for the geostationary spacecraft. For the newer spacecraft, such as the METOP second generation, we will actively steer it down through the atmosphere so it burns up within a few weeks of the end of life.
Well, Gareth, thank you for showing us around. Can you tell us how long it does take to prepare a satellite mission?
It takes a long time. It's a complicated and expensive thing to do, and it can take many years to generate the design for the satellite and to build it, to design what the ground segment is going to be, and to put together all the pieces to turn the data from the satellite into the actual products that the users need for the service. You start off with the mission requirements. You have something called Phase 0, Phase A, which is looking at, what do we need? What sort of data do we want to have in 10 years, in 15 years time? And then you design a system around that, assuming that you actually can design a system. You maybe have to do some technology development, have some pathfinders for that. And then eventually you work your way through all the number crunching in terms of the costing and the scheduling and so on, placing contracts. And eventually you end up with a satellite that's sat on a launcher, ready to go, and a ground segment ready to operate it.
In the end, but how long is long? 5 years? 10 years?
It can take a long time. The first discussions about the METEOSAT second generation happened when I was still at university. So in the mid to late
just a
1980s.
few years ago.
Yeah. Yes, it was 3 years ago. So from mid 1980s until the first satellite was launched in 2002.
But doesn't things just develop faster and faster nowadays?
It depends. There are different ways of doing things. With these kind of satellites, when you really have to be absolutely confident that you're going to give the data that you need reliably, then you need to put a lot of effort and a lot of time into designing the system and into preparing it so that it's fully reliable. You can't just bang a satellite together and launch it and hope it works, because that's not the way Murphy's Law works.
No. Well, I can understand, but thinking about the changing in the worlds and the coming up of Elon Musk and satellites launching and stuff like that, I can imagine that it's completely different world than, let's say, 10 years ago. So that might go quicker and quicker in the coming years.
Yes, but again, you take the Starlink system that SpaceX is launching. They're launching hundreds, thousands of these satellites. If they lose a few of them, it doesn't matter, and they replace them very quickly. With a METOP or a METEOSAT spacecraft, there are billions of euros invested in these things, and they have to work and they have to be reliable. And that means that you take the time to do it right.
But do you
can't necessarily follow the same approach. I'm sorry?
Do you see more cooperation in the future with guys like Elon Musk or someone else who's starting something like that up?
Potentially. I mean, EUMETSAT has been cooperating internationally for decades, especially with NOAA and with other agencies around the world who have a similar role to the one that we have. We're already looking at how we can make use of some commercial data as well to complement the information we get from our own satellites. So there are options for the future, certainly.
And well, I have to ask the question to you as well. What is your dream for 2030?
It's not fair. Mark stole a really good one, which is to see this climate temperature curve start to trend, to peak and start to come down would be nice, but I think that's a long way away. I've got 4 kids, and so I want to see the world better for them than it is as it looks right now.
Do you think EUMETSAT also has new tasks to look what's happening on the moon or Mars, because people are walking around there?
I'm not sure if our role will extend quite that far. Our focus is to observe the Earth's weather and the climate and the oceans, and to provide services that mean we make our people's lives better. We improve lives, we save lives, and we find ways of curing some of the problems that we have at the moment.
And we've got enough problems here on this Earth, so let's focus on this part of the universe. Mark, I don't know if you're still there. I can't see your image anymore, but maybe you can hear me, because there was a question about
was it the archive?
The archive, that was it. Yeah,
the archive. Yes,
it would be great if
So-
EUMETSAT got an archive. Thank you.
Yeah, and we agree. So what's happening is we're saving all of the imagery that goes onto the view surface. We're saving, so that will build up the archive. So we just need the Earth to rotate and time to pass. And by the beginning of next year, we will have a whole year's archive.
Yeah, of course. I can imagine. Yeah, and I think the biggest challenge maybe is not collecting the data, but trying that we could find the data easily. So you're not the best kept secret on the internet, right?
Yeah, and that's a huge challenge, actually, trying to get all of it, because we have a stunning array of data, and trying to get organized so that it's simple to find is actually quite tough.
It is quite tough. Is there anything else you would like to add to the viewers? One of you.
For me, I think some of the information, and it was mentioned in one of the questions, about what we call the nowcasting SAF products. So these are products that are associated with severe storm development. And I think we can really encourage people to use those, particularly with when MTG and EPSSG come. To have those inside the viewer, for me, would be really good. But we're user driven, so we need people to tell us what they need.
That's true. And Gareth?
I come from the other end of the operations department, as it were, where we're it's a bit like making sausages. You don't ever want to see how it's done. So we make the sausages, and then Mark is the one who actually makes them available to the users. So we're looking at better ways to operate our spacecraft and better ways to make the data available faster and with higher quality. And we're also looking at what we do to preserve the space environment as well. So we're looking at how we avoid polluting the space environment with debris, with old spacecraft, and how we bring them safely down to Earth or place them and they won't make things more difficult for future generations.
And you work at the same organization. When was the last time you saw each other in real life?
Actually, it might have been last week.
Quite a while.
But I think that was the first time.
Oh, okay. Well, I didn't actually see you because I had to drop down off at Mark's house.
Oh, that's right.
Yeah.
Yes.
Yes.
We had a small flood, and they helped us out.
Okay.
So that was I think the last time in probably 18 months that we'd actually seen each other.
Yeah, I think so.
Yeah.
I think so.
Well, we really would like to see you next year in real life, if possible. That would be great.
That'd be nice.
I think I'm ending this part of the session. We've seen a lot this morning about how EUMETSAT works, but also how much EUMETSAT can offer to us as weather forecasters, as journalists, as climate journalists. And there's much more to discover. I didn't have the time yet to go to the partner sections or to look at any comments. So I would like to take the time now. And some other people might have time to lunch or to do something else. We will be back at 13:30, so 1:30. We say 1:30, 1:30, 1:30. And in the meanwhile, we have enough food for thought now. Let's take time for food in real life. Use your time to exercise or to go into the system. There are 400 competitors, participants to discover. So I hope everyone now has put in his picture, has put in the right description. So you can go to the chat room, you can make connection. There's so much to discover, and that takes time as well. So don't forget to take a look at Swapcard. And if it doesn't work, refresh. It's always the best way. I wish you a nice refresh, and we'll be back after lunchtime, and we go to Africa, focus on Africa and a decade of the oceans for sustainable development. It will be a great afternoon. Gentlemen, for so far and for all the speakers for this morning, thank you very much. See you all.
Thank you.
Thank you very much.
Have a nice break.